Ever wonder what's actually running the show behind all the automation we hear about these days? It's like the brains behind the brawn of these massive industrial setups.
Oh yeah, we're talking PLCs. And to be honest, before we dove into this, I had no idea what they were. I bet a lot of people don't, even though they're everywhere behind the scenes.
Exactly. So let's break it down. What is a PLC? Every time I hear about them, I imagine some supercomputer running an entire factory.
You're not far off. Think of it like a computer, but instead of sitting on your desk, it's built to handle the toughest conditions imaginable. Way tougher than spilling coffee on your keyboard.
Way tougher. We're talking scorching heat, freezing cold, dusty environments, places where your laptop wouldn't last 5 minutes.
Makes sense. These things are on factory floors, not exactly cozy office spaces.
Right, but the real magic is what they're designed to do: control. They take in information from the real world, follow instructions we program into them, and then tell the machines what to do.
And we're talking real-time, precise control, right? Not just a delayed response.
Exactly. Instead of a bunch of humans flipping switches and pushing buttons, the PLC can handle it all based on, guess what? Some kind of code.
One of our sources even mentions this guy, Richard Morley, known as the father of the PLC. Back in 1968, factories were using these huge systems of relays and timers, wires everywhere.
Yeah, talk about a nightmare to troubleshoot. It was complex and inflexible. If something went wrong, good luck.
That's where Morley's invention, the PLC, came in. It basically revolutionized everything. No more tangled webs of wires, just elegant code.
Pretty much. Suddenly, you could control super complex processes with lines of instructions instead of miles of wiring. It was huge for the automotive industry at first, then spread to almost every industry you can think of.
From clunky relays to elegant code, no wonder he's called the father of PLCs.
But let's dive in a bit more technically. What's under the hood of a PLC?
At the core, there are three main parts. Imagine it like this. You've got the CPU, which is the brain calling the shots. Then you have the I/O modules, which are like the PLC's senses.
So the CPU makes decisions, and the I/O modules feed it information, like what's happening in the real world.
Exactly. The I/O modules pick up signals from sensors that tell them things like temperature, pressure, or whether a button has been pressed. That's all the data the CPU needs to make the right call.
Okay, so that's how the PLC knows what's up. But how does it actually control machines?
That's where actuators come in. They're like the muscles of the system. The PLC tells them to control valves, motors, conveyors, whatever's needed.
It's this constant loop, sensing, thinking, acting, all happening at lightning speed.
And to make this whole automated ballet work, we need a way to tell the PLC what to do in the first place, right?
So we've covered the basics of what a PLC is. Now let's dive into those languages. Where should we start?
The most popular one, especially for beginners, is called ladder logic, or LD for short.
Ladder logic, that sounds interesting.
Picture this. Two vertical lines, like the sides of a ladder, represent the flow of electricity. The rungs connecting them each represent a different operation.
I think I can picture that. So how does that control a PLC?
Well, on those rungs, you use symbols like in an electrical diagram: switches, relays, timers. So instead of physically wiring components, you're building a virtual circuit diagram.
That's clever. And because it's visual, it's easier to understand the logic behind it.
Exactly. If this sensor is activated, close that switch and turn on the motor. Simple and intuitive.
But our sources also mention another language, structured text, which sounds more serious.
Yes, structured text, or ST, is more like traditional coding. Think Pascal or BASIC. You'd use it for complex calculations or algorithms with lots of decision points.
Like adjusting a motor speed based on temperature readings, for example?
Exactly. You could whip up code to take that temperature reading and convert it into a specific motor speed.
Makes sense. So ladder logic is the visual, intuitive option, and structured text is more code-heavy. What else is in our PLC toolbox?
There's instruction list, or IL, which is closer to the hardware, almost like assembly language for PLCs.
Sounds intense, definitely for hardcore programmers.
It's efficient, but most folks stick to ladder logic or structured text. Then we have function block diagram, which is visual like ladder logic, but uses blocks to represent functions.
I love how you can visualize the entire process with that. And then there's sequential function chart, right?
Exactly. SFC is perfect for processes with a very specific sequence, like filling, capping, and labeling bottles on a production line.
This is fascinating stuff. It's like we're learning the language of machines.
Totally. And after another quick break, we'll check out some real-world examples of PLCs in action.
All right, we've covered the basics of PLCs and the languages they use. Now let's see them in action.
Exactly. One of the most common examples is a conveyor belt system in a factory.
Oh yeah, moving products along a production line.
Right. The PLC is the traffic director, controlling everything from stopping and starting to speeding up and slowing down.
So it's constantly reading data from sensors and making decisions in real time.
Exactly. And a good programmer plans for the unexpected, like what if a bottle tips over?
The PLC would know to stop the belt or trigger an alarm for human intervention.
Yep, it's like a supervisor who never sleeps. But on a massive scale, PLCs can run thousands of processes simultaneously.
That's incredible. And the future for PLCs sounds even more futuristic.
Oh yeah, with IoT integration, PLCs will be talking to each other, optimizing processes, and predicting failures before they happen.
The factory of the future is looking pretty amazing, but also brings up concerns like security.
For sure, cybersecurity is critical in these systems. As things get more interconnected, we need to ensure they stay secure.
So it's about balancing innovation with reliability and safety. The future sounds both exciting and challenging.
Definitely, but humans will still be in the loop, collaborating with these intelligent systems.
That's a relief. Well, this has been a deep dive into the world of PLCs. If you're curious to learn more, keep exploring.
The future of automation is wide open, and who knows, you might end up programming the machines of tomorrow.